Okay, problem 11. Suppose the position of a body moving along a coordinate line at time t. So S is A cosine kt plus B sine kt. Right. And first, what is ds over dt? It is, so this part, the derivative is A negative sine kt times this part, right, k, plus B, right, sine something, the derivative is cosine kt, then times t's coefficient, right, k. So it is negative ak sine kt plus bk cosine kt. Then the second part, what is d square s over dt square? So it's just a derivative, d over dt. It's just this part's derivative, right? The second order derivative is just the first order derivative's derivative. So just d over dt, negative ak sine kt plus bk cosine kt. Right. So let's do it again. Sine something, right? The derivative is negative ak. Sine something, the derivative is cosine. Then t's coefficient k, right? It is k. Plus this part bk. Cosine kt's derivative is negative sine kt, right? Times t's coefficient k. So it's negative ak square. Okay, let me write it this way. K square a cosine kt plus right, because the negative sign is outside, plus k square b sine kt. Okay, so it's negative k, right? It's negative k square a cosine kt plus b sine kt. Right, and this is exactly s, right? So in the end, you can write it as negative k square s. Okay. So why it's directed to the origin? You can think about it in this way, right? This is the origin when it's 0. So as long when the position is on the right side of the origin, s is positive, right? For example, 2, right? S is positive, then the second order derivative, which is the acceleration, right? The second order derivative, it's the acceleration. It is smaller than 0. So as long as the object is here, right, the acceleration points towards the origin. For example, if the object is here, right, you can see if it's here, then the s is negative. S is negative, s is smaller than 0, then negative k square s, it's greater than 0, right? So the acceleration is pointing towards origin. So the acceleration is always pointing towards the origin.